Good day, everyone. For today's video, I will be presenting to you additional information about the greatest common divisor or GCD of two or more integers. In my previous video lecture, I discussed the GCD of two integers, but now I'm going to discuss the concept further. And let's talk about the GCD of two or more integers. But before that, let's have first a recall about the GCD of two integers. So recall here that the GCD of two integers a and b is the greatest integer that divides both a and b. So we have here a notation for the GCD of a and b. So we have here the notation, say the GCD is D. So this is the GCD of A and B. Okay. So based from our definition, it is the greatest integer that divides both A and B. Hence, we can say that the GCD of A and B is D if, and only if, we can write D, we can have D divides A and D divides B. So based from our definition, so D divides both A and B. So let's have here an example. Say A is 3 and B is 6. So here, we know that the GCD is 3. Why? Because 3 divides, which is our D, 3 divides 3, and we know that 3, the GCD, divides 6, which is B. So that's it. Now let's have here another term. We call A and B relatively prime if its GCD is 1. Now here in our example, take note that the GCD is 3. Hence we can say that 3 and 6 are not relatively prime here. So let's have another example. Say, let's have here A is equal to 3, and then say B equals 7. Now, the GCD of 3 and 7 is obviously 1. Follow? Because the divisors of 3 are 1 and 3, because 3 is a prime number. So here, divisors of 7 are 1 and 7. Hence, we have here our GCD, the greatest common divisor of 3 and 7, which is 1. Now, in this case, we can say that 3 and 7 are relatively prime. Okay? So, because the GCD of 3 and 7 is 1. Again, in our first example here, 3 and 6 are not relatively prime. Why? Because its GCD is not equal to 1. It's 3. So let's now proceed to our topic for today's video. Let A1, A2, up to A sub n be integers. Take note, these integers here are not all 0. Now, the greatest common divisor, or the GCD of these integers, is the largest integer that divides all of the integers in the set. So notice here, we are to get the GCD of A1, A2, up to A sub n. So we have here the notation. We are using the same notation, but we are here getting the GCD of more than 2 integers, or it could be 2 or more integers. So to simplify, we can have A1, the GCD of A1, A2, A3, up to A sub n is equal to D. Say, this is the GCD of A1, A2, up to A sub n. Now, the same definition for our GCD of 2 integers. We can write this one if and only if our GCD, which is D, divides A1, D divides A2, up to D divides A sub n. Okay? So we have this one. Now let's have here examples, or let's consider this example. Let's have A1 be equal to 4. Say A2 here equals 6, and say A3 equals 8. Take note here, n is up to 3, so which is equal to 3. We have A1, A2, A3. We are considering here 3 integers. So we will try to find the GCD of these 2 integers. But before that, we will try to look at the divisors. So for the divisors of 4, we have 1, 2, and 4, right? Now, for the divisors of 6, we have 1, 2, 3, and 6, right? So for the divisors of 8, we have 1, 2, 4, and 8. Now take note here, we have 2 common divisors. We have 1 common to both 3 integers, and we have here 2, which is common to both 4, 6, and 8. Now, take note that when we talk about GCD, we are looking at the greatest common divisor. Now here, in our example, the greatest common divisor is 2. Hence, we can write the GCD of 4, 6, and 8 is equal to 2. Why? Since 2 divides 4, 2 divides 6, and 2 divides 8. Okay? So based from our definition here on the left. Now, let's have here another term. We call it as mutually relatively prime. Now, the integers A1, A2, up to A sub n are said to be mutually relatively prime if the GCD of these integers is equal to 1. They are mutually relatively prime. Now, recall that for the GCD of 2 integers, as discussed a while ago, that if they are relatively prime, its GCD is 1. Now here, we call it as a mutually relatively prime for 2 or more integers. So the same concept that their GCD is equal to 1. Now let's consider an example here. So let's have name this as example 1. So let's have here example number 2. So let's have A1 be equal to 3, A2 be equal to 6, and then A3 be equal to, say, 7. Now, let's try to look at the divisors of each integer so that we can find here the GCD of 3, 6, and 7. Now, here, the divisors of 3 are 1 and 3. Here, for 6, we have 1, 2, and 6. For 7, we have 1 and 7. Okay? So, as you can see here, we have the common divisor. And it's the greatest common divisor, which is 1. So, it's 1. Hence, we can say that our greatest common divisor for 3, 6, and 7 is equal to 1. Hence, 3, 6, and 7 are mutually relatively prime. So here in this example, since we have this, the GCD is 1. Although the GCD of 3 and 6 is 3, as can be seen here. By the way, 3 is also a divisor of 6. So we have here, we also have here 3 and 6. Okay, so take note here, as you can see, 3 is common divisor of 3 and 6. However, it is not a common divisor of 7. So let's proceed. We have here pairwise relatively prime. Now, when can we say that the given integers are pairwise relatively prime? So the integers a1, a2, a sub n are called pairwise relatively prime if for each I not equal to j, we have this pairing. So the GCD of 2 integers is 1. So in other words, every two integers, its GCD is 1, or every 2 integers are relatively prime. So here, that's why it's called pairwise. So we are going to pair. We have 2 integers and then test if every 2 integers are, or we are going to test if 2 integers are relatively prime. Every pairing of 2 integers. So we will show that they are relatively prime. So we call it pairwise relatively prime. Now let's consider example. So let's have example number 3. So let's write it here. Okay, let's have example number 3. So let's consider A1 be equal to 3, A2 be equal to 14, and then A3 be equal to 25. So in this case, we have 3 integers. So to test that the pairwise relatively prime, we will be testing pairs of integers rather. So we can have A1, A2, or we have, say, A1, A2 is equal to, we have the GCD of 3 and 14. Another one, we have another pairing. We'll get all the combinations except when I is equal to j. It should be I not equal to J. So we have A1. Another pairing, we have A3. Take note, we cannot get A2, A1 because the GCD of A1, A2 is the same as A2, A1. Okay? So we will only get A1, A2. So here, A1, A3, we have A1 is 3, and then A3 here is 25. Next, we have combination. We have A2 and A3. So this is equal to the GCD of 14 and 25. So again, we will get all the combinations. So if we will consider 4 integers here, so you have more pairings than this. Okay, so you will get all the combinations of every pair of integers, except for this one, A1, A2, because they are the same as A2, A1. So let's try to get the divisors of 3 and 14, because we are to test here for A1 and A2. Now, for this pairing here, for A1 and A2 here in the first, we will get the divisors of 3. So we know that the divisors of 3 are 1 and 3. And then for the divisors of 4, we have 14 rather, we have 1, 2, 7, and 14. Now, here, the GCD of 2 integers here, as you can see, we have 1. Follow? Hence, the GCD of 3 and 14 is 1. Okay? So let's try to find A1 and A3. So in that case, we have here, let's have here, we have A1 and A3. So in this case here, for A1 and A3, let's try to look at the divisors of 25, okay? Because we're done finding the divisors of 3. So let's have here divisors of 25. We have 1, 5, and 25. Okay, so we will be focusing on the 2 here, the 2. So take note here, we will focus here and here. Now, as you can see, we have 1, 3 here, we have 1, 5, 25. Hence, we have the common divisor, or we call it the greatest common divisor, which is 1. Therefore, we can say that the GCD of 3 and 25 we have here, it's 1. Now, let's proceed to, by the way, let me color this blue here, okay? So let's have the other pairing. We have here 14 and 25. So we have this one. We have 14 and 25. So 14 and 25 focus on the last 2 numbers here. So as you can see here, for 14 and 25, by the way, let me change this to black for consistency. So that is one. Black means 4, 3, 4. The GCD for 3, 4. Red means the GCD for 3 and 25. And then blue means the GCD of 14 and 25. So as you can see here, this one here, as you can see, the greatest common divisor is 1. Follow? And so we can say that the GCD of 14 and 25 is 1. Now take note, we have all the pairings of our given integers, and we have found out that the GCD of every 2 integers is 1. Hence here, we can say that 3, 4, 40. Again, we can say that 3, 14, and 25 are pairwise relatively prime. So this means a pairwise relatively prime. So here in this example, the integers 3, 14, and 25 are pairwise relatively prime because we have shown that every pairing of integers, the GCD is 1. So here, notice here that this one, these integers here, 3, 14, and 25, are mutually relatively prime. What do you mean by mutually relatively prime? That if we are going to get the GCD of 3, 14, and 25, this is equal to, as you observe here, in the list of divisors of each integer, we can say that here, the GCD of 3 integers, we have 3, 14, and 25 is equal to 1. Hence, from our previous definition, we can say that 3, 14, and 25 are mutually relatively prime. Hence, here, we can say that pairwise relatively prime implies mutually relatively prime. So let me abbreviate it this way. It means that every pairwise relatively prime is a mutually relatively prime. Just like here, because we have shown that 3, 14, and 25 are pairwise relatively prime, then it is true that they are mutually relatively prime. Now, what about the other way? Does it hold? Here, in this way, it holds. What about the other way? Does it follow that every mutually relatively prime here is a pairwise relatively prime? Okay, let's try to look at our previous example here, example number 2. So in example number 2, here we have shown that 3, 6, and 7 are mutually relatively prime. So we have shown this one. The question is, do the 3 integers pairwise relatively prime? So let's try to find out. So we will get the pairing of this. So for the pairing we will get 3, 6. Another we have 3, 7. And we have 6, 7. We know that there are 2 common divisors. For 3 and 6, we have 1 common, and so with 3. But then we are to get the greatest common divisor. So the greatest common divisor of 3 and 6 is 3. So the GCD of 3 and 6 is 3. Now for 3, 7, as you noticed here, its GCD is 1. Then for 6, 7, GCD is 1. Now notice here we have a pairing of pairing of integers. We have 3 and 6, wherein the GCD is not equal to 1. Therefore, we can say that 3, 6, and 7 are not pairwise relatively prime. Why? Because we have here the pairing of integers in which that the GCD is not equal to 1. So it should be 1 all, so that you can say that the given integers are pairwise relatively prime. Hence, in this case, if the given integers are mutually relatively prime, it does not follow that the integers are pairwise relatively prime. Hence, this is not true. Okay, the other way. So we have here, notice that if the given integers are pairwise relatively prime for this. So if the given integers are pairwise relatively prime, then they are mutually relatively prime. And the other way does not hold. So that's all about the greatest common divisor of two or more integers. I hope you have learned a lot from this lecture. So thank you for watching and listening. Goodbye, everyone.